Hello, physics students. So we've discussed the difference between position and velocity. We've discussed the difference between displacement and distance. Today we want to discuss the difference between velocity and speed. These are two different quantities in physics. Now we'll start with the same picture of the table that we had before. Let's put our same little bug friend back in there. All right, so remember our bug started at this end of the table. And we said that this was the starting position x0. The bug ran 4 meters along this edge of the table. Then turned the corner and ran 3 meters across this end of the table, and it ended up with a final position here. And we discovered that the distance and the displacement were two different quantities, where the displacement is represented by the hypotenuse made up by the sides of the table, but the distance traveled, the actual length of the path, the distance d was simply equal to 3 meters plus 4 meters, or 7 meters. And that is a scalar. And we saw that the displacement or delta x worked out to be the square root of the two sides added together, which was the square root of 25, which was equal to 5 meters in the northeast direction, and it is a vector. So let's say I have a stopwatch and I'm actually timing the bug moving around the table. And let's say that we measured that the time that it takes the bug to move from the starting position to the final position, let's say that worked out to be 10 seconds. Now, distance was a scalar. Displacement was a vector. A change in time is also a scalar. Now, in our everyday speech, we often use the words speed and velocity interchangeably, but they're not. In physics, speed has the meaning of a distance traveled divided by the time to travel that distance. Remember, distance is the length of the path, not the displacement. So the speed of this bug is going to be equal to distance over time. Or d divided by delta t. Now, that's simply going to be equal to 7 divided by 10. So that's 7 meters divided by 10 seconds, or 0.7 meters per second, where meters per second is a derived unit. It's a combination of the fundamental unit meter for length and seconds for time. Now, distance was a scalar, time was a scalar, so this is we're dividing two two scalars here. So speed is a scalar. Well, we define the average velocity not with distance but with displacement. So that will be the displacement over time. Well, that's going to be 5 meters divided by 10 seconds, or 0.5 meters per second. Now, it's the same motion, but we're describing it two different ways. One way I could use is the speed, that is distance divided by time. That's a scalar quantity. But this is a vector. Velocity is a vector quantity. The velocity is a vector delta displacement divided by time. So I need the direction specified as well. Well, time doesn't contribute anything to the direction. So the direction for the velocity is going to be the same as displacement. So I should say that this is 0.5 meters per second this way, or in the northeast direction. And I should remind us that this is a vector quantity. So, two different things. Now, technically, we should say that this is not just a velocity, that this is an average velocity. Since the displacement only matters where you start and where you end and doesn't have any of the real information about what happens in between, this is really an average. Next class, we'll talk about how we become a little bit more precise than just dealing with an average velocity. But sometimes you'll see it written with AVG as a subscript to bring home the fact that this is an average velocity. Average, that is the average velocity over the 10 seconds that the bug was moving. And this is a very important equation. So the velocity does not depend on a choice of reference frame. So velocity plays a much more important role in physics than speed. You can place your origin anywhere you want in a problem, and you will calculate the same velocity for a moving object. So there we go. That's the difference between distance and velocity. Here are some important points from this lesson. Speed is defined to be the distance traveled divided by the interval used. That is, I would calculate speed using the following equation. Speed equals distance over time. Mathematically, that would be d divided by delta t. It is a scalar quantity, but has the same unit as velocity, that is meters per second. Notice that we do not have a special symbol defined for speed. Speed, because it's a scalar quantity, is not useful in motion equations. So we work with velocity is what has to be used instead of speed. Velocity. Velocity is a vector quantity, so we can stick some arrows on these variables. Velocity is a vector quantity having both size and direction. Velocity is calculated by dividing the displacement by a time interval, delta t. So the velocity v is always defined by displacement divided by time. Velocity and displacement vectors point in the same direction. Although velocity and speed have the same unit, they are not equivalent.